Now that we've gained some experience with working with different types of radicals, we're going to begin to solve square roots and other types of radical equations. Now in solving radical equations, there's a simple procedure to follow. So if an equation has a variable inside of the radicand, there are three basic steps. The first is to isolate the radical, meaning that if there is anything being added to or subtracted on the outside or any multiplying or dividing outside, you need to get the radical by itself. Once that radical is isolated, you need to raise it to the nth power. So if our radical was a square root, we would square both sides of the equation. If it was a cubed root, we would cube both sides. Whatever it takes to get the radical symbol to become neutralized or become a power of 1. Third, we solve for the variable. So whatever operations were happening to our variable inside of the radicand now need to be undone using inverse operations. So through these three steps, solving for the radical of course being sad meg, we can solve equations involving square roots and higher orders. So let's look at a few examples. If I have the cubed root of x plus 4 equal to 9, I'm going to follow those three steps in order to solve for x. First is isolate the radical, which it already is. Next, I'm going to raise to the nth power. Since I have a cubed root in my equation here, I'm going to raise this to the third power. And I will do the same on the opposite side. Sorry, not square root, third power. There we are. Now what that does is it eliminates the root on the left side, so I end up with just x plus 4 equal to 9 to the third power is 729. Next, I need to solve for the variable. So inside the radicand I had addition. I'm going to subtract 4 from each side. I end up with x equals 725. Now, good idea is to go back and check our work. So let's do that. I want to do the cubed root of 725 plus 4. And I want to know, is that equal to 9? Order of operations, group first. So I have the cubed root of 729. Want to know, is that equal to 9? Well, this is the cubed root of 9 cubed. Is that equal to 9? And I get 9 equals 9. So this checks out. Now, let's solve the other one. I have 4 plus the square root of 2x minus 7. Sorry, 2x minus 1 equals 7. And I'm going to solve for x. First step is to isolate the radical. I have outside of my group here this positive 4 that needs to be gotten rid of. So I'm going to subtract 4 from each side of my equation. I end up with the square root of 2x minus 1 equal to 3. Next, because my radicand here does not show an index, it's automatically assumed to be a square root, I am then going to square each side of my equation. This gives me 2x minus 1 equals 9. Now I will solve inside of the radicand. Add 1 to each side. I get 2x equals 10. Divide by 2. And I come out with x equal to 5. Now again, want to check to make sure that this works. So I'm going to go 4 plus the square root of 2 times 5 minus 1. I want to know, is that equal to 7? So I begin simplifying my left-hand side. I have 4 plus, I'm going to save a few steps here. Square root of 2 times 5 is 10, minus 1 is 9. And I want to know, is that equal to 7? So I get 4 plus 3 is that equal to 7? And I come out with 7 equals 7. So that checks out also. Now, when we're dealing with just basic roots, square roots, cubed roots, fourth, any integer root, we can solve using this method. But what happens when we have a rational exponent? Let's take a look at that. So if I have an exponent that is m over n, I will raise it to the n over m power to cancel it out. If m was even, then you must use absolute value, keyword being must. So let's begin solving this problem. 3 times the cubed root of x plus 1 squared plus 2 equals 14. I'm going to begin by isolating my radical. I'm going to subtract 2 from each side. So I get 3 times the cubed root of x plus 1 quantity squared equals 12. Next, I will divide both sides by 3. And I come out with the cubed root of x plus 1 squared equals 4. Now, rewriting this with a rational exponent, I come out with the group x plus 1 to the 2/3 power equals 4. Now, in order to eliminate that 2/3 power, I'm going to raise both sides to the 3/2 power. Now, my rule up here applies. M was even. I had a 2 in my numerator. So I will get the absolute value of x plus 1 equals 4 to the 2/3, or sorry, 4 to the 3/2 means the square root of 4 cubed. Square root of 4 is 2, 2 cubed is 8. Absolute value of x plus 1 equals 8. So I'm going to make two equations of x plus 1 equals 8 or x plus 1 equals a negative 8. Solving, I subtract 1 on the left, I get x equals 7. Subtracting 1 on the right, I get x equals negative 9. And now, I need to go through the process of checking both of them. So I want 3 times the cubed root of 7 plus 1 squared plus 2. I need to know, is that equal to 14? So I get 3 cubed root of 7 plus 1 is 8. 8 squared is 64. Plus 2, is that equal to 14? I get 3 times 4 plus 2. You know, is that 14? 3 times 4 is 12. Is that equal to 14? And I have 14 equals 14. So, x plus 7 checks out. Let's try the next one. Let's go with x equals negative 9. So I have 3 cubed root of negative 9 plus 1 squared plus 2, is that equal to 14? Well, we have 3 cubed root of negative 9 plus 1 is negative 8. A negative 8 squared is 64. Plus 2 is supposed to be equal to 14. This is 3 times 4 plus 2. So I get 12 plus 2. And I end up with 14 equal to 14. So the positive 7 checked out and the negative 9 checked out. Both are valid answers. So I come up with x equals 7 or x equals negative 9. Let's check situations where extraneous answers are possible. If I have square root of x plus 7 minus 5 equals x, I'll solve the same general method. And we'll begin by isolating my radical. I will add 5 to each side. And I come out with the square root of x plus 7 equals x plus 5. Now, since I have squaring here, square rooting, I need to square both sides. On the left-hand side, that gives me x plus 7. And that has to equal x plus 5 squared, comes out to be x squared plus 10x plus 25 if we FOIL it by itself. Now, solving a quadratic, I'm going to subtract x plus 7 from the left and subtract x plus 7 from the right. That gives me 0 equals x squared plus 9x plus 18. Two numbers that multiply to 18 and add to 9. I have 0 equals x plus 6 and x plus 3. Solving these individually using the zero product property, I have x equals -6 or x equals -3. Now going through and checking these, I'm running a little bit out of room, so we're going to check them shorthand. We have the square root of -6 plus 7 minus 5 is supposed to equal a -6. -6 plus 7 is 1, square root of 1 is 1. Is 1 minus 5 equal to a -6, -4, and -6 does not work out, so not a solution. That one's extraneous. Checking the other, we'd have the square root of -3 plus 7 minus 5. Need to know, is that equal to -3? -3 plus 7 is 4, square root of 4 is 2. 2 minus 5, is that equal to -3? -3 equaling -3, that checks out. So our answer is x equals -3, the other is extraneous. Now what happens if we have multiple radicals inside of our equation? What's going to happen here is I will add the square root of x to each side. So I come out with the square root of 2x plus 1 equals the square root of x plus 1. Now I will square both sides of the equation. I get 2x plus 1 equals square root of x plus 1 squared. I will get x plus 2 root x plus 1. Now going through and solving this, I'm going to subtract x and subtract 1. 2x minus x is just x. 1 minus 1 is 0, equals 2 square root of x. Now at this point I can square both sides. So I thrown in basically an extra step here. It just becomes one step longer with multiple radicals. I get x squared equals 4x. Solving this, subtract 4x from each side. I get x squared minus 4x equals 0. Well, that factors to x times x minus 4 equaling 0. So x equals 0 or x equals 4. Now going through and checking to see if these work, I would have the square root of 2 times 0 plus 1 minus the square root of 0 equaling 1. 2 times 0 is 0, plus 1 is 1, square root of 1 is 1, minus square root of 0 is 0, equals 1. I have 1 equals 1. Now, going through and checking the second solution of 4, we have the square root of 2 times 4 plus 1 minus the square root of 4 is supposed to equal 1. 2 times 4 is 8. 8 plus 1 is 9. Square root of 9 is 3. Square root of 4 is 2. So I have 3 minus 2 equals 1. Sure enough, 1 equals 1. So both check out. Both are valid answers. A lot going on in here in solving equations, but this is the first step in solving equations involving radicals. Check back over the solutions and the methods here. Take good notes and be ready to use this moving forward in Algebra 2.